Hello, today I wanted to show you one of the easiest way and also the quickest way of solving equations with fractions. So here's how this technique works. We always start by asking ourselves what is the common denominator between 5 and 4, or the lowest common multiple or the lowest common denominator between 5 and 4. And in this case the answer would be 20. So because 5 times 4 will give us the 20. So what we are going to do is we're actually going to multiply the numerators with 20. So multiply the 4 by the 20 and also the 1 by 20. However, when you use multiplication, you got to multiply every single term, including the term on the other side of the equation. Okay, so you got to make sure every single term gets multiplied by 20. Now something interesting happens when you multiply by the lowest common multiple. Now the 20, the reason why I'm putting the 20 next to the 4 is because the 20 does not multiply the denominator, it only multiplies the numerator. Okay, so 20 times 4 will give us 80, and that will stay over 5. X. Bring down the subtraction sign, and then we do 20 times 1, which will give us the 20, over the 4x, equal to, and on this side we still have to multiply the 11 times 20, which in our case will be 220. All right, now the next step is to simply divide now the numerator with the denominator. So 80 divided by the 5 will give us 16x minus 20 divided by the 4 will give us 5x equal. Now on this side we cannot simplify anything because 11 never had a denominator, so you just simply bring down the 220. So here's what just happened here. By multiplying the numerators by the lowest common multiple of the denominators, what we did is we made the numerators divisible by the denominators, so that gave us whole coefficients instead of having a fraction coefficient. All right, and you are allowed to do that as long as you multiply every single term by the same amount. Okay, so let's go ahead and combine the like terms here. 16x minus 5x will give us 11x equal to 220. And now to isolate the x, we gotta cancel out the 11, the coefficient. Since 11 is multiplying the x, that's 11 times x, we gotta divide both sides by the 11. So in the end we get x equal to, well, 220 divided by 11, if you look up here, we know it's going to be 20, because that's how we got the 220 in the first place. So the final answer for the x is 20. All right, so I find this to be one of the easiest ways of solving equations with fractions. It's very easily understood by a lot of students from my experience, and I just wanted to show you. Now I'm also going to show you a slightly quicker way of doing this. In the beginning I multiplied the 20 by the 4 and then divided it by the 5, which I did over here. But you can actually, before you multiply the 20 by 4, you could simplify it with a 5 and the 20 with a 4, so you don't have to deal with such large numbers. And I will explain in the next slide what I'm talking about. So let's go ahead and move on to our next example. Now if you want to give this one a try, by all means feel free to go ahead and give it a try. All right, so same process as the last one except for one step, and I will show you that right now. So first question is, what is the common denominator between 9 and 5? And the common denominator, or one of them, would be 45, because 9 times 5 will give us 45. So I'm going to go ahead and multiply the numerator by 45 Now, as soon as you multiply one term, you have to do to every single term. So I'm going to multiply the 1 by 45 as well as the 87 by 45. All right. Now, this is the method I was talking about. Instead of multiplying now 45 by 4, which will give us a very large number, what we can do is we can actually go ahead and simplify the 45 with a 9. And here's what I'm talking about. Simply ask yourself, how many times can 9 go into 45? And it has to, because it is a multiple of 9 and 5. So the answer would be 5, because that's what we used. So the 45 becomes a 5, the 9 becomes a 1. So what I'm technically doing is dividing 45 by 9, which will give me 5 over 1. And I do the same thing with the 45 and the 5. The 45 in this case becomes a 9, and the 5 underneath becomes a 1. Now, on the other side, I cannot simplify this because there is no denominator. So I'm going to have to multiply and get the answer. Now, before I do that, let's go ahead and write the answer. Now, to get the answer now, what I'm going to do is, instead of multiplying the 45 by 4, I multiply the remaining factor, which is the 5, with the 4. So here I will get 5 times 4, which is 20. Now this would be 20 over 1, since the 9 became a 1, but we don't really need a 20 over 1, because 20 divided by 1 is still a 20. So this will simply become 20x. And here I'm going to do the same thing, 9 times 1, which, oh, before I do that, let's bring the plus down, the addition. And then I do 9 times 1, which is 9x. And now we don't need the 1 underneath it, because 9 divided by 1, it's just going to be a 9. Bring down the equal. And now here we're going to get a relatively large number. We have no choice. 87 times 45 will give us 3,915. Okay, but again, we were able to get rid of the denominators by using the common denominator or common multiple of 9 and 5, which was the 45. Let's go ahead and combine like terms here. So this will give us 29x equal to 3,915. Divide both sides by 29. And our final answer, x, will be 135. Because 3,915 divided by 29 is 135. Now, I also wanted to give you an example when you have more than just two terms that are fractions, and also what would happen if they all are the same amount. By that, I mean if they're all the same denominator. Let's go ahead and take a look at our last example. All right, take a minute here to look at this. Feel free to give this a try on your own. All right, so in this case, this should be relatively easy because they all have a denominator of 3. Now, before we go ahead and multiply every single term by 3, I need to focus on the 13 and 1/3. And the reason being is because 13 and 1/3 is actually a mixed number. Now, in order for this technique to work properly, you're going to need to turn this 13 and 1/3 into an improper fraction. If you don't remember how to do that, all you have to do is take the whole number in front, the 13, multiply it by the denominator, and then you add the numerator. So let's go ahead and do that underneath it. 13 times 3 is 39, and 39 plus 1 will give us 40. 40 becomes your new numerator. The 3 stays as your denominator. Now, the reason why you want to do this transition from a mixed number to an improper fraction is because when we multiply every single term by the 3, in the original version, the 13 and 1/3, it's a mixed number. So when you multiply by 3, you might misunderstand it as 13 being the actual final answer. But in reality, the 13 represents the number of whole fractions in 13 and 1/3. The 40 is the true numerator. 13 is not the numerator here. That's why you need the actual numerator for this technique. So let's go ahead and bring everything else down. 5/3 x plus 1/3 x. I'm not doing anything to change this. Plus 8/3 x. All right, now I'm going to go ahead and multiply everything by 3. I'm going to do that with different colors, so times 3. Again, I only need to multiply the numerator, not the denominator. You're not supposed to multiply the denominator, in fact. So times 3 times 3. Okay. Now, you don't even need to multiply 3 times 5 because 3 divided by 3 cancels out right away into 1 and 1. So you can actually go ahead and cancel every single 3 that you multiplied with the 3 that's dividing. All right, and you are allowed to do that because as you make the equation 3 times greater, the denominators are making it 3 times smaller, so they will cancel each other out. So that will leave you with 5x, because this is a 1. 1 times 5 is just 5. So this will be a 5x plus, this will stay as 1x equal, this will remain as a 40 plus, and this will become 8x. All right, and now you can see that the reason why we had to turn the 13 and 1/3 into an improper fraction, because if you leave it as a mixed number, you might have gotten this constant number as a 13, which in reality it is the 40, not the 13. Okay, let's go ahead and combine like terms here. We can combine the 5x with the 1x here because they're on the same side. That will give us 6x equal 40 plus 8x. Now normally I would recommend to move the smaller x term, but since 6x is already by itself, it's already isolated, and our goal is to separate the constant from the algebraic term, I'm going to go ahead and move the 8x toward the 6x so that I can solve right away for the variable afterwards. And to do that, to move 8x to 6x, I got to do the additive inverse of addition. That would be subtraction. So I'm going to subtract 8x on both sides. Again, I'm using the balancing method here. Whatever you do to one side, you have to do to the other side. These two cross out, leaving me with just the 40. Bring down the equal sign, and then 6x minus 8x will give me negative 2x. All right, and finally, I'm going to divide, but now the coefficient is a negative, so I got to divide by the negative 2 on both sides. And finally, x is equal to negative 20. All right, so that concludes today's lesson. Feel free to ask any comments, make any suggestions, and give me any other suggestions about a future video, any topics you would like me to cover. And with that, I'm going to go ahead and conclude this video.